Okay, so in this part we're going to label the ties and struts. So I'll do this in blue. So what I'll do is I'll just label them here on the space diagram. In an exam, what you could do is sketch it out again, just so it's a bit clearer. But I'm going to mark these up with ties and struts. So remember, if the two arrows are pointed in on each other like this, it's going to be a strut. And if they're pulling apart, it's a tie in tension. So struts are in compression, ties are in tension. So it might be easy to start with some ties. So the bottom of the truss is always going to be ties, okay? These are always in tension, so we'll show the arrows pointing in on each other like this. Okay, so those three are ties. Are there any ties? So also in this truss, this is in tension, and this one is in tension. Okay, because the truss is pushing down, so that's been pushed out, so it's kind of been pulled apart there at the joint. So that's a tie, and then everything else in that truss is a strut. Okay, so we'll mark that up as struts. So these two pulling apart, these two are being pulled apart, these two, this one, and this one is the same. And then we have this one is a strut, and this one. If you look at the lecture on ties and struts, I've a good few examples of trusses up there, and it shows in red and blue colours which parts of it trusses or different types of trusses would be ties and struts, so you can have a look at that as well. So what I'll do now is I'll continue this video on. I'll just zoom this out a little bit, and what we need to do now is tabulate the forces in each of these members. So what you want to do is make a little table for yourself down here. So we'll say if it's a strut and if it's a tie. So make some columns like this, and then what you can do is if you go back to our diagram at the top there, I've said which are ties and which are struts. So if we say, what we can do here, we can well AF and DJ are the same. Then we have BG and CI are the same, so they can go on the same line. You could have separate lines as well. JE and EF are the same, and EF are the same. IJ and FG are the same. EH is on its own. You can also tell in this diagram here which are very similar, which are going to be similar size. And then IH and GH are going to be the same as well. Okay, so from this diagram here, sorry you can't see that, I'll zoom that out a little bit. So is it a strut or is it a tie? So that comes from this diagram here, because we've already identified what is a tie and what is a strut. So I'm just going to work off the force diagram now, and I'm going to use the scale ruler to scale off my different members and my different forces. Okay, so I'll start with AF. So scale 1 is to 100. So mine is shown there is 65 kilonewtons for that one. So 65 kilonewtons, and it's a strut. BG, where's BG? This way. So BG is 39, actually it's 40 kilonewtons. JE and EF are a tie and they're the same, so JE and EF, this is the same line here, so that's 57 kilonewtons. IF and FG are the same, so we'll measure one of those. IF is 25. EH is 29. Sorry, that is a tie. And IH or GH, they're going to be the same, so just measure one of them. And that is 15 newtons, and that's a tie as well. Okay, so strut, struts, tie, strut, tie, tie. Okay, so they're just scaled off your force diagram here. And that's the end of example 7. Okay.